Hi everybody, thanks to be here with me for this talk about an experiment in continuous deployment of JVM application. I'm Nicolas Frankel. I've been working as a consultant, as developer, as team lead, in different technical roles in projects. And because I had enough of projects and deadlines and let's say not super achievable goals, 2 years ago, or nearly 2 years ago, I decided to be a developer advocate. The good thing with this role is it allows me to have those crazy ideas and to try to implement them, which is the role of this talk. I work for a company called Hazelcast, and Hazelcast, we have two different products. The first one is IMDG, in-memory data grid. You can think about it like distributed data structures. So you have the niceness of your hash map or queue or whatever under the same or very close to the same API, and then your data structure is distributed along several nodes. The other project that we have is called Hazelcast Jet, and I will use it in this talk, so let's not go too much into detail. So continuous integration, we have been doing continuous integration for a long time. I mean, the idea of continuous integration, of bringing all work from all developers in a single point and to check that everything works together, has been like nearly there since I started working, as I mentioned, like nearly 20 years ago. So we want to make sure that everything compiles together, that everything can be unit tested together and up until the storing in the registry. In general, I hope that every one of you has this continuous integration pipeline in place, that when you start compiling, then you commit, then everything is handled in this pipeline. And of course, the contents, the steps in the pipelines might be specific, but the fact that you want to compile, that you want to unit test, that you want to package, that you want, well, this is in general what we are doing. But continuous stuff doesn't stop there. As I mentioned, continuous integration should be the norm. Again, the exact steps might depend on your context, but continuous integration in general should be the norm. Whereas we can go a bit further, and this bit actually is very, very, very far away. Like you have continuous delivery, which means that you will be doing the same, but you take the package that you have just created and you deploy it to production, and it sits there just waiting the release by, in general, a business owner that gives a go and they say, yes, let's deploy it for real. And then you have this continuous deployment, which means that there is no decision at all, that the commit of the push of a developer like triggers the whole pipeline, and in the end the code is deployed into production. And to be honest, I've not seen it in my career. Only big companies do it, because there is one big problem with that, is you shouldn't have any downtime. And the problem of the JVM is that the traditional deployment of JVM application, whether you are using a jar or war, is to stop the JVM. Then you deploy your application, which means like overwrite the old package, and then you start the JVM again. And again, this is true for like application servers. You bring down the application server, you deploy your new application, and you start it up again. Or for this new model of self-executable jars, it doesn't change a thing. And the problem with downtime is that, in general, if you have internal users, they can be warned about it. They don't like it so much, but it's acceptable. As soon as you face customers, then it's not really acceptable. Like, for example, if you have Facebook or Gmail or whatever, they don't have the concept of downtime. So people are getting used to this no downtime model, and they don't understand when you have this static page saying, hey, please wait a bit, we are coming back in a few minutes. Especially if you in some domains such as e-commerce, like every second of downtime is second where you don't sell and where customers will go to your competitors. So going down is not really feasible. And of course, in order to cope with that, we have some existing pattern already. For example, you might know about this blue-green deployment. So you have two contexts, two environments. They are completely mirrored. One of them is the production, the other is a pre-production. So for example, in the image here, the green is the production and the blue is a pre-production. So you set everything up in the blue environment, you deploy your new application, and when you are ready, you switch the arrow of the router from the green environment to the blue environment, and of course, everything is fine. Well, of course, everything is not fine. It's not easy as it appears. Like, there are a couple of issues. Like, if you have two databases, how do you instantly copy the data that is written on the green environment to the blue environment until the last second? Of course, you can say, oh, but I will have a single database. But then if you have schema changes, it might be a bit harder to cope with. There are ways, but they are not super fun. Kubernetes rolling update, of course, if you use the Kubernetes platform, then you can say, oh, then it's easy. I will just do rolling update of all my nodes, and in the end, I will have the right application. Again, it's not the problem of the compute node. The problem lies in the state, the database, and how do you handle database changes. And then we can say, oh, but let's keep everything as it is and just try to change the bytecode inside the JVM and without any downtime. How can we do it? It sounds a bit like magic, and probably it is if you don't know about those tools, but actually it's possible. So first, let me tell you about something called the attach API. And the attach API is like very easy concept. It allows you to load an agent from a running JVM from another JVM. So you have this production JVM, and you run a new JVM that will attach new code into the running one. And the good side of it is it doesn't need to run, the production JVM doesn't need to run in debug modes. You have only two requirements. They need to run onto the same system, whether it's a virtual machine or a real operating system. And the attaching JVM must know the PID of the running JVM. So those are only the two requirements. And the model is quite easy. You have this virtual machine here, which has a static method. You say, hey, attach to these PID, and it will create a new virtual machine. And then you can load an agent. So you must know the path to the agent jar, and we will see just afterwards what I mean by agent. You can pass in some string, and it's done. So in 2 lines of code, you can achieve that. Again, with those two requirements, run on the same system and knowing the PID. And so, Java agents. First, one must understand that Java agents are not like wild beasts. You might have heard the term before. It's just specific jar. An agent is just a jar with dedicated metadata. And this metadata is in the manifest.mf. And this is part another API called the Instrumentation API. And the Instrumentation API allows to change the bytecode of running application. And if you have used monitoring tools of Java application in the past, that's exactly what you are doing. You are using the command line to point to the path of an agent on the same system, and using the Java agent option on the command line. But this is only one way to actually use an agent. As I mentioned, there are two ways. There are the static one and the dynamic one. And the dynamic one is by using the attach API that I've just mentioned. And to create an agent, it's very easy, depending on whether it's a static or dynamic, but basically they are mirrored. On the static side of things, you have this pre-main method. So in the normal executable jar, you have this main method, which must be public, static, void, must be called main, and accepts an array of string. And here it's the same. It's a pre-main method, and it accepts an array of strings as well, and also an additional interface that will be provided by the JVM called Instrumentation. I will talk about it in just a few moments. And on the dynamic side of things, the signature is the same, just is agent main instead of pre-main. And just as in a self-executable jar, you have this main class in your manifest.mf. On a static agent, you must have a pre-main class, and a dynamic agent, you must have an agent class. And of course, if you both have the methods and both metadata into the same jar, then you can have an agent that can be used as a static agent and also as a dynamic agent. So both are possible. A jar can be both a static agent and a dynamic agent. And with instrumentation, you can do very interesting stuff. The thing that we will do here is, of course, we will change the existing implementation of the class. Of course, there are limitations that you cannot overcome, but still you can do a lot. Or otherwise, you can apply automatic transformation of bytecode. So when a class is loaded into the JVM, then you can do something like automatic and always the same, just as adding attributes or whatever. The model of the Instrumentation API is also quite easy. You have this interface here called Instrumentation, as I mentioned, is passed to you by the JVM in the pre-main or agent main class. And as I mentioned, you can add an automatic transformer here. And you can see that if you are using the new Java module system, it's also module friendly. So you can do it even when you are doing modules, if your application is like module compatible. And here we will use, in our use case, this redefine classes method. And basically what you are doing, you are passing this class definition. And class definition is just a class itself with the bytes of the class files. So to create a class definition, you just have an already existing class and the bytecode of the new implementation that you want to have, and then you create this class definition, you call redefine classes, and presto, you will have this new running bytecode inside your JVM. Now, there is one final question, is we know how, when you have a running JVM, to attach itself to it and to have this new code, but how do you move the bytecode, this new code? How do we move it around? There are basically two options. The first one is batching. So every now and then we will call the batch and say, oh, we will take the new bytecode and move it around. Or we have this streaming model, which seems much, much better, because it means that if nothing happens, like if there is no new code, then we won't deliver the existing code. And as soon as you have new code, then it will be moved around. So I believe the streaming model is much better adapted. We will use an in-memory stream engine, and you might know about some of them. So in the cloud, like every cloud provider proposes one. So you have Amazon Kinesis, IBM Streams, Google PubSub, this kind of stuff. You can also have a processing engine on-premise, so just as Flink or Jet. A special mention to Beam because it tries to abstract implementation dependent processing engine. Of course, it's a leaky abstraction because there is no standard in this domain, so it's an afterthought that try to take the common port of all engine and try to make an abstraction on top of them. It's a good effort, I think, but it's very leaky. Anyway, let's talk about Jet. So it's an Apache 2 open source license jar. You can use it as a library, so embedded in your application. You can also use it in the client server mode, so you will just like launch the jar and your application will be the client. The good thing about Jet is basically the batch and streaming API are unified, so you can use Jet as batching, so with a definite start and end when all items have been processed, or as streaming, so until you get while you get items, you will deliver them. And the change to go from one batching to streaming is just adding a timestamp. It's very, very easy to move from one to the other. So if you are more familiar with batching, then you can start with batching. And then when you get more used to streaming, you can change your model to streaming in one line of code. This is the possible infrastructure of Jet. On the left, you can see there are like the inputs are the sources, and this is what Jet can read from by default or by some extensions. And if you don't have here what you want to read, for example, I don't know, a dedicated file because the file watcher doesn't suit your need, there is an API so that you can create your own. On the opposite, here you have the targets, the sinks where you can put your data, the output, and in the middle you can have, as I mentioned, Jet. So here you can, of course, like combine different streams of data, and you can do like distributed computing. And then, of course, if you know about Java 8 transforms, you can do exactly the same. You can do map, you can do filter, this kind of stuff. The good thing about Jet is that it's very well integrated with IMDG. So basically, if you have like you want to enrich a stream with some data that sits in IMDG, then it's made for that. And since everything is in memory, it's very, very fast. So back to our application. Now we have all the pieces. We have the attach API, we have the instrumentation API, and we have the streaming API. So let's bring everything together. I will have my streaming. Well, let's talk about first the production JVM. It runs the app, and this is self-contained, and it will just need to allow the attach API. By default, if you have no security manager, the attach API is open, which can be an issue. So just think about it. It might also be a security issue. But here for this talk, this is very good. And then we will have this injection JVM that will run, that will basically load the jar of the Jet job and actually inject it into the app. And basically what it will be doing is that the app now will be listening to the Hazelcast IMDG changes. And so on the other side, we will have this streaming JVM, which can be on a completely different machine that will read the file system of the developer, of the CI, or whatever. I mean, it can read changes from a folder and read new classes, and which will deliver them to Hazelcast IMDG. So every time there is a change, this app now, which have enhanced capabilities, will listen to the change and will redefine the classes inside. from a dynamic point of view, from a flow point of view. First, we will start the jet job. So it will loop and constantly read if there are changes. If there are changes, it will put them in the Hazelcast IMDG map. Then we will have the agent that will attach itself to the production JVM and will make this production JVM subscribe to change into the Hazelcast map. And every time there is a change, then the production JVM will be triggered. It will read the changes and it will reload the bytecode. And now there is time for a demo, because otherwise it's just like talk. So here I've created this application and I want to have this source. So this is my production JVM, and basically my production JVM is just a simple servlet, a very, very simple servlet. And here, sorry, this is my, sorry, this is not my production JVM. This is what I will be working on. My production JVM is here, this hello servlet. It's actually the same. And here I have a main class which launch an embedded Tomcat and use this servlet as to display it. So I will just run this. And here, very important, I just run it like normally, no debug mode. And now if I go there and I do hello, I have this hello world. Wow, amazing. Second step. So this is in production. This work is in production. So I will close it and I will forget about it. I just need to have like the existing source here in my IDE, sorry. Now, what I will do is I will attach myself to this running application. And this running, the attaching itself, as I mentioned, is very easy. Here I have Kotlin code, but you can do it in any JVM language you want. 2 steps. You get the PID, and because I didn't want to have a manual process to check the PID of the existing production JVM, I just have a function that computes it automatically because it knows the main method. And then I load the agent, and loading the agent is as easy as that. So, and I have a path to the update agent that I've created previously. So I will attach myself to the agent. And meanwhile, I will just start the streaming job. So now the agent has been attaching itself to the production JVM, and I have a streaming job that basically sees that there is no change and tells me no change, no change, no change, no change. Great. The update agent is the one where the magic happens. Of course, it takes a bit of resources on my machine. So this is what I attach to the production JVM. And basically what it does, it will add a bytecode change listener. So when there is a change, then it will get the name out of the event, because in the IMDG, I will have put the class name and I will have put the bytecode itself. And so basically when there is a change, I will call the instrumentation and redefine classes. And the instrumentation, I get it because I have stored it from the agent main changes. So now everything is set. I will just need to change here the class which sits in my source folder. So here I'm completely unrelated to the production JVM. And when I change here, saying hello world, I will say hello stackconf. And I just need to compile. So when I compile, the target classes will get updated. The Jet job will read it, will send it to IMDG, and the production JVM will be made aware of it and will reload the classes. If I refresh my running JVM, I will see hello stackconf. And it works for anything I can type here. Okay, I can write something else here, out.write. Yeah, sorry, I don't have any ID of smart stuff to say. I compiled the hello servlet, which sits in my source, and magically on my application, on my running JVM, I have the stuff that I want. Let's stop this because it takes a lot of resources of my machine. And let's get back to the slides. So of course, there are limitations to this like simple demo. The first, if you are not used to continuous deployment, if you are used to, hey, let's create a jar, put the jar in the package registry and with a tag, then here I have no tagging. And this is part of the continuous deployment stuff. Once you start doing continuous deployment, you don't have like very specific artifacts with versions. So if you are not comfortable with that, if you want to have specific versions, it's hard to do continuous deployment. Another limitation is because of the redefine classes method, you have no loading of new classes. So by redefining, here I don't handle loading of new classes. I could have done it, but I didn't do it because it's more work. Also, the redefine classes tells you that you have some limitations. So for example, you cannot add, remove, or rename fields or method or whatever. You are limited to changing the implementation of the class. You can also not change the inheritance hierarchy because it would break a work with the whole JVM loading model. However, you can. It's already a lot of stuff that you can do. If you want to go further, if you want to build upon this demo, because perhaps you think it might have been a good idea, then you cannot stream from the developer machine, because then every developer would stream from his own machine. There would be no continuous integration anymore. But you can do the same with streaming from the CI pipeline. So the source wouldn't be the folder on the developer machine, but the folder on your continuous integration server. This works pretty well. You can also add, if you want to have tags, for example, you can also add additional tagging metadata in each class. For example, if you take your stream from Git or from the CI pipeline, then you probably have the Git tag somewhere, and you can like inject the tagging metadata in each class. So you know, hey, this class is from this commit. So it's also possible. So thanks a lot for your attention. I hope you like it. You can read my blog where I publish a weekly post on Sunday evening. You can subscribe to my Twitter account, which is always nice. And more importantly, if you are interested to dig a bit further, or because the demo was a bit fast, you can get the code on GitHub and like clone it and perhaps change it and adapt it to your needs and see how it works in more details. So thanks a lot for your attention and have a good stackconf.